All right, let's talk about the internet. Not the websites you see, but all the stuff happening behind the scenes. We're going to pull back the curtain on the invisible plumbing that makes the whole thing work. It's this huge, kind of wild system of pipes, addresses, and rules that we're using every single second. So let's get into it.
Okay, so to wrap our heads around all this, we're going to use one really simple idea that makes everything click. Just imagine your computer isn't a computer at all. It's a house. And all that data flying around the internet, think of it like water flowing through a massive city's plumbing system. Got it? Cool. So if your computer is a house, then every house has to be on a street, right? And every house needs an address. That's the first piece of the puzzle in our digital plumbing system. Figuring out where everything is actually located in this giant digital city. And that street we just mentioned? Well, in tech speak, that's a network. It's really just a bunch of connected devices, your computer, your phone, all those servers out there that have all agreed to talk to each other and share stuff. Now, not all streets are the same. You've basically got two main types. First, there's your private little cul-de-sac, the LAN, or local area network. That's your home Wi-Fi. It's super fast, it's small, and it's all yours. But then you've got the global highway system, the WAN, or wide area network. And yeah, that's the internet itself, connecting pretty much everything to everything. And just like a real house on a real street, every single device connected to a network needs its own unique address. I mean, how else would the data know where to go? This is its IP address. It's literally the house number and street name for your computer out there on the internet. But here's the crazy thing. With the old address system, IPv4, we actually ran out of addresses. For real. The internet just got too big. The solution was basically to build a whole new planet of addresses. It's called IPv6. And look at that thing, it's huge. This wasn't just about adding more computers, This is what makes the whole Internet of Things possible, giving a unique address to literally everything from your smartwatch to your smart toaster. Okay, so we've used the IP address to find the right house. Great, but how does the data get inside? And how does it find the right room? Turns out, your computer doesn't just have one front door. It has, wait for it, this many. 65,535. No joke. That's how many potential doors or ports your computer has. And every single one is a possible gateway for a different kind of information. And each of these doors leads to a very specific service. Like when you're browsing a secure website, your data is knocking on port 443. Sending an email? That's probably going through port 25. This whole system makes sure that the stuff for your web browser doesn't accidentally end up with your email client. It keeps everything organized. But, having over 65,000 doors is, it's a bit of a security nightmare, right? And that's where firewalls come in. You can think of them as the bouncers for your digital house. They're standing at the entrance, checking IDs, and deciding which doors are open, which are locked tight, and who's even allowed to get close. All right, so the data has found the right house. It's gotten through the correct door. Now what? Well, for two computers to actually understand each other, they need to speak the same language. They have to follow the same rules of conversation. And that set of rules is called a protocol. Honestly, the best way to think about it is like grammar for computers. It defines how data should be sent, how it should be received, and how it should be understood, so nobody gets confused. And there are two main ways computers talk. First up, you have TCP. Think of it like sending registered mail. It's a little slower, it's very careful, and it makes absolutely sure that every single piece of data arrives safe and sound and in the right order. This is what you want for loading a web page. But then you've got UDP. This is more like just tossing a bunch of postcards in the general direction of the recipient. It's way faster, but if a few get lost along the way, no big deal. This is perfect for stuff like video streaming or online gaming, where speed is everything. So, to guarantee that reliability, TCP does this thing called a three-way handshake before it sends any real data. It's actually a super polite little conversation. The client basically asks, "Hey, can we talk?" The server replies, "Sure, I hear you." And then the client confirms, "Awesome, I'm ready." It's that final confirmation that locks in the connection and makes it so stable. So we've got this really elegant system, right? Addresses, doors, languages, it's all designed to work perfectly. But what happens when people try to mess with it? Let's take a look at how this exact same system can be exploited when the plumbing breaks. Okay, remember that unique street address, the IP address?
Well, IP spoofing is when an attacker basically writes a fake return address on their package. They send out something malicious, but they make it look like it's coming from a computer you trust. This can trick systems into letting their guard down. That's why good network security involves blocking data that claims to come from places it shouldn't.
And what about all those doors we talked about? Port scanning is basically a hacker walking around your digital house and methodically trying the handle of every single one of those 65,000 doors and windows, just looking for one that's been left unlocked. And your best defense against this? A really well-configured firewall that makes sure only the necessary doors are even visible from the street.
Now, once data is actually moving through the pipes, it can be vulnerable to something called packet sniffing. This is the digital version of a wiretap, and attackers just listening in on any unencrypted data, trying to grab things like passwords or private messages. And this is exactly why encryption, that little HTTPS lock you see in your browser, is so important. It scrambles the whole conversation, making it total gibberish to any eavesdroppers. And maybe the sneakiest attack of all is the man in the middle. This is where an attacker secretly puts themselves right in between two people who are talking. They intercept all the messages, they can read them, they can even change them, and then they pass them along. The two victims have no idea. They think they're talking directly to each other, but really, they're both talking to the attacker. Using something like a trusted VPN, especially on public Wi-Fi, creates a secure private tunnel that basically kicks that man out of the middle.
So here's the bottom line. We've just walked through the entire blueprint of the internet's plumbing, from the huge global network right down to the tiny rules of conversation. You now get the system that powers basically our entire digital world. Which leaves us with just one final question to think about. Now that you know how the plumbing works, are you checking your own systems for leaks?